Okay, that's good. All right, so we got to do the unit circle today. This should really be all review. You should feel super confident by the time we're done with this. You might have seen this exact lesson before, but you know, mine will be better. So here we go. All right, so first of all, we talked yesterday about some of these angles, right? Let's start there. So 0 degrees, 90 degrees, 180 degrees, 270 degrees when we go around those quadrants. Also remember that, you know, you're going to have to know this forever. So we don't want to just try to memorize this for a couple days, okay? This is like, we got to really lock this in. So we're going to see where this is derived from rather than just memorizing. So now we can also take, oh, this is 360, right? Once you make that full revolution. So then you can take each quadrant and you can break it up into quarters. So then we're at 45 degrees. Adding that next 45 took us to 90. Another 45 is 135. Then 180. Then what? 225. Then 270. Then 315. Making it back around to 360. But then you can take each quadrant and divide it up into thirds. So you can count by 30 degrees. So 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and then making your way back around to 360. The degrees are the easiest part of the whole thing, right? So you shouldn't have any trouble with that. But now we have to think about the radian values. Sometimes those are a little harder. So this is 0. And then let's do the same thing. So let's hit those compass points there. So this is pi over 2. And then we come to pi. And then 3 pi over 2. And then back around to 2 pi. But now if we break it up into quarters, okay, so then I can count by pi over 4. So pi over 4, 2 pi over 4 simplifies to pi over 2. And then 3 pi over 4, 4 pi over 4 is pi, 5 pi over 4, 6 pi over 4 takes us to that south location, but that simplifies to 3 pi over 2, 7 pi over 4, and then finally making our way back to 8 pi over 4, which is 2 pi. Then back to those thirds. So I can do pi over 6, and now I'm adding pi over 6 each time. So when I add pi over 6, I get 2 pi over 6, but that simplifies to pi over 3. That means that this is 3 pi over 6, but that's simplified to pi over 2. 4 pi over 6 then is 2 pi over 3. And then 5 pi over 6, 6 pi over 6, we're back to pi, 7 pi over 6, 8 pi over 6 simplifies to 4 pi over 3. This is really 9 pi over 6, 10 pi over 6 simplifies to 5 pi over 3, and then 11 pi over 6, we're almost back around to 12 pi over 6, which is 2 pi. So far, so good? Yeah? You okay? You remember all this? Okay. Now we're going to talk about the coordinates. So that's like the big stuff. That's the harder stuff to remember, and that's really what we really need. So first of all, this is called a unit circle. So it means that the radius is 1. Okay? So what is this location here? What should this coordinate be here? 1, 0. The x value is 1, and the y value is 0. So then at 90 degrees, I'm at 0, 1, and then at pi, negative 1, 0, and then finally at 3 pi over 2, I'm at 0, negative 1, okay? So, this is all of the stuff you could probably still do. The other stuff is a little bit harder to remember. So, now what we're going to do is we're going to turn our paper over, all right? So now we got to do some thinking. All right, the first thing I want to do is I want to take a trip down memory lane back to geometry, okay? So when math was easy, it's good days back then. But this part in geometry goes a little rough sometimes. So let's talk about special right triangles for a second. Do you remember a 30, 60, 90 triangle? Yeah? Okay. So that was a special right triangle. So here's 30, here's our 90, and then 60 degrees. Okay? Now, there was a special pattern that these side lengths followed in a 30, 60, 90 triangle. Anyone remember it? Hassan?
Okay, the 40 side is X, and then like
I'm going to call it A. Can I use a variable A? Is that okay? Okay.
and then the bottom one is 2A, and then the hypotenuse is A root 3.
You have them switched. A root 3 is smaller than 2A. Remember, your hypotenuse always has to be the largest side. So this is 2A, and this is A root 3. Nice memory. Okay, so this is the pattern that the 30, 60, 90 follows. Okay, but now we are going to relate it to the unit circle. So the unit circle has a radius of 1. Think about where that value of 1 is. Isn't this the radius of our circle? Right? The hypotenuse? So that means that this side is equal to 1. So if I take that rule and I set it equal to 1, so 2A equals 1, that means that A is 1/2. And now everywhere I see an A, I'm going to plug in 1/2. So I get 1/2 times root 3, which is root 3 over 2. And here I just get 1/2. So here are all my side lengths. Now I want you to think about this right here. If I wrote this as an ordered pair, think about what your x value would be. Your x is your horizontal distance. What's my horizontal distance? Square root of 3 over 2. My y value is my vertical distance, and that is, in this case, 1/2. That should look vaguely familiar to you. Turn it back over, and this is where the super cool part comes in. So now take your ruler, and I want you to drop a line down here. Let's see. Let's do it this way. Do you see this triangle right here? What is this angle? What's that angle right there? Stop coloring. I'm going to give you a chance. What's this angle right here? 30 degrees. And this is 90, so this has to be 60. So that's where that root 3 over 2, 1/2 coordinate comes from. Okay, it's not magic. It's not just someone chose that coordinate to work with. They chose the messiest thing they could find. It's because there's a 30, 60, 90 triangle sitting there. That's cool. Right? But hang on, it gets cooler. Because if you look over here, do you see that this is also a 30-degree angle here? There's another triangle sitting here. That's a 30, 60, 90. Okay? Think about the rules of reflection. Just listen for a second. Then we're going to take a second to therapeutically clear our minds. So just give me a second. So think about what happens. If you take a coordinate and you reflect it over the y-axis, what happens? What do you do?
Negative.
Negative what? X. You change the sign of x. So that means this coordinate is negative root 3 over 2, positive 1/2. But wait, there's more. Because there's another 30, 60, 90 sitting here. What happens when you take this coordinate and you reflect it over the x-axis? The y changes signs. So now we have negative root 3 over 2, negative 1/2. But one more time it happens. There's another triangle sitting here that's a 30, 60, 90. And it follows the same rules of reflection. If I take this point and I reflect it over the x-axis, it has to change the sign of y. So I get root 3 over 2, negative 1/2. I want you to draw in your triangles, and I want you to color them all the same color. I am clearly an expert colorer. Okay. You like how that all goes the same way?
I don't like.
That's like mom coloring. You got to get it done as fast as possible so you can be done with that awful project.
It sounds like you have a personal resentment towards projects.
Okay,
But wait.
I'm moving on. So you can come back to your
Not
coloring.
done.
I know, you all want to just keep coloring.
But wait, there's more.
You need another minute?
Yeah.
Fine, one more minute.
The 30, 60 triangle.
You don't have to. This is your unit circle you're going to keep for the rest of the year. So we need it to be right. That's the most important part. Not that it's pretty, but that it's right.
You normally record during the third hour? Hey, we judge.
I never
people
record.
being
All my
pretty.
videos are already recorded.
Well,
make
For
it
some
like
reason,
about-
this one's missing.
You can't say that. It's like a parent and their favorite children.
Aaron had like 10 children. Like, I love you guys, all of you.
That's a lie.
Okay, turn it over. I'm moving on.
There's not going to be a 10-way tie.
Let's talk about a 45, 45, 90 now. That one was the easier one. If you remember back to geometry, that's the easier one to remember.
Oh, because the square root 2 and square root 2?
Because it's like an isosceles right triangle, right? So these legs have to be congruent. So let's think about the pattern. Here's our 45 degrees, our 90, so that makes this angle here 45 degrees. Anybody remember the pattern? Assad, go ahead, take it home.
The two equal sides are A, and then the hypotenuse is A root 2.
Nice. You're like a geometry master. Okay, so A root 2. Now, the same deal is happening, right? We're still talking about the unit circle, so our radius is still equal to 1. That means this side length is 1. So to find A, I can take A root 2 and set it equal to 1. Divide by root 2. But then what do you have to do? Yep, rationalize, multiply by the square root of 2. So A is the square root of 2 over 2. So everywhere I see an A, I plug in the square root of 2 over 2. That should look familiar to you as well, because this also creates a coordinate, where x is the square root of 2 over 2, and y is also the square root of 2 over 2. And if you turn this back over, you'll notice that those 4 triangles appear again. Okay, so the rules of reflection get applied just the same as they did before. We create that 45-degree angle here. So we have that 45, 45, 90. That's where root 2 over 2, root 2 over 2 comes from. And then you want to go through and you want to apply the rules of reflection. So which signs do you change? In quadrant 2, I should have negative root 2 over 2, root 2 over 2. Quadrant 3, everything is negative. In quadrant 4, x is positive and y is negative. Choose a different color and color those triangles in. Since we're recording, I'm going to let you come back and color. We'll just finish it up and then you can finish coloring at the end, okay? So let's turn it back over. There's one more triangle we have to talk about. And you might be thinking right now, there's no other special right triangle that exists, and you would be right. But now we're just going to look at a different orientation. So 60, 30, 90 triangle this time. So this time at the origin, we have that angle of 60 degrees, which makes this angle 30 degrees. It's still a 30, 60, 90 triangle. So we still get A root 3, and 2A. And our hypotenuse is still equal to 1. That means that 2A equals 1, so therefore A is a half. And I do the same thing that I've been doing each time. I'm going to take that 1/2 and I'm going to plug it in everywhere I see an A. When I get those side lengths, that's going to create this coordinate where my x value now is 1/2 and my y value is root 3 over 2. Okay, so now if you turn it back over, you'll see that those 4 triangles are created one last time, where at that origin you're creating your angle of 60 degrees, which makes these others 30 and 90. So this is 1/2 root 3 over 2, and then you have to follow the rules of reflection. So negative 1/2 root 3 over 2, negative 1/2 negative root 3 over 2, and then positive 1/2 negative root 3 over 2. I want you to take a second and I want you to make sure you have all the coordinates written correctly and all the signs written correctly. Remember that in quadrant 1, both signs have to be positive. Remember in quadrant 2, your x is negative, your y is positive. In quadrant 3, both are negative, and in quadrant 4, x is positive and y is negative. Okay, so that's also a good check that you can do. And then finally, you're just going to choose your last color and color those triangles in. Now I'm going to show you one more thing, and then you can finish coloring. I'm sure at some point along the way, somebody probably taught you a trick. Okay, now I'm sure that at this point you kind of know me. I'm not really into tricks, right? Like I'm kind of into like knowing where all this came from, getting that deeper knowledge. But there are a few things that sometimes I still go to. And really, first of all, the main one is really just understanding that if you know quadrant 1, you know the whole thing, right? Because it's all just reflections. So that's a huge, huge piece. But the one trick I'll do is sometimes I'll count. So like it goes 3, 2, 1, 1, 2, 3. 3, 2, 1, 1, 2, 3. So I can remember it that way. And then the y values do the opposite. 1, 2, 3, 3, 2, 1. 1, 2, 3, 3, 2, 1. You remember that? Everything's over 2. You have radicals in the numerator. It's just the square root of 1 is 1. Okay? So I think that's all I really want to say about this. All right? Hopefully you remember this. All right? Sound good? Do you have any questions? Okay.